Well, hello students, welcome back to Mathematics Specialist class with me, Mr. Alfie. At the previous meeting, we have learned about proving by direct and indirect proof. Now we're going to learn how to prove with another way. Let's check this video out. Now we're going to learn about proof by induction. What is proof by induction means? Mathematical induction is a deductive method to prove a statement to be true or false. It is needed to draw conclusions based on the truth of generally accepted statements so that specific or certain statements can also be true. These are the following steps. The first, prove that the formula or statement is true for n equal to 1. And then the second, assume that the formula or statement is true for n equal to k. And then the last one is prove that the formula or statement is true for n equal to k plus 1. Now, let's jump to the example. So, 1 plus 2 plus 3 plus blank 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 plus n equal to 1 per 2 and multiple with n plus 1. So, this is what you call specific statement, and then this is the general statement. So we're going to prove that this statement is true. The first step, prove that the formula or statement is true for n equal to 1. So if n equal to 1, this addition only finishes at the first one. So 1 equal to, and then we substitute value of n to this general statement. 1 per 2 multiple with n plus 1. So by calculation we find that 1 equal to 1. So it is true for n equal to 1. This statement is true. And then the second statement. Assume that the formula or statement is true for n equal to k. So we substitute the value of n equal to k to this whole statement. So the statement becomes 1 plus 2 plus 3 plus blank 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 plus k equal to 1 per 2 times k plus 1. And then the third step. Prove that the formula or statement is true for n equal to k plus 1. So this is the formula when we substitute n equal to k. Now we are going to find the statement n equal to k plus 1. So the first thing we need to do, we add k plus 1 to this side and also plus k plus 1 to this side. So the statement becomes 1 plus 2 plus 3 plus blank 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 plus k plus 1 equal to 1 per 2k equal to k plus 1 plus k plus 1. So we add k plus 1 in this side and also k plus 1 in this side. So we are going to prove that this statement is true by these following steps. So this is the statement when n equal to k, and then we add k plus 1 to this side and also k plus 1 to this side. And then this is the original statement, 1 plus 2 plus 3 plus blank 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 plus n equal to 1 per n multiple with n plus 1. So now we substitute the value of n equal to k plus 1 to the original statement. Now we got that 1 plus 2 plus 3 plus blank 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 plus k plus 1 equal to 1 per 2. Remember, substitute every value of n with k plus 1. This n, k plus 1 multiple with k plus 1 plus 1, it's k plus 2. Now since the left side are the same as you can see here, so we just need to prove that this equal to this one. If this general statement equal to this general statement, so the statements are true. So this statement is true. Now we're going to prove this statement equal to this one. So the statement we're going to prove is 1 per 2 k multiple with k plus 1 plus k plus 1. So we simply to multiply 1 per 2k with k and 1. So 1 per 2k multiple with k is k squared per 2, and then 1 per 2k multiple with 1 equal to k per 2. And then because these are per 2, we make denominator in this one is 2. So it is 2k plus 2. Now, since all of them have 2 as a denominator, we can put denominator 2 as multiplication of 1 per 2. So 1 per 2 multiple with k squared here plus 3k, it comes from k plus 2k equal to 3k plus 2. Now we simply just need to factorize this one, and then we'll got that 1 plus 2 plus 3 plus blank 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 plus k plus 1 equal to 1 per 2 k plus 1 multiple with k plus 2. So it is proved that the original statement is true.